leaders from Johor Matriculation College, and I am Pengrian from MS26.
Hi, I am ARINA from MT22.
Hi, I'm TASNIM from MS25.
Hi, I am SERENE from MS31.
So now we will start our Power Mini Symposium of Chemistry subject about the topic Born-Haber cycle. So we will get prepared for our PSPM too. So let's get started. So first of all, I will explain the words that will be used in the Born-Haber cycle. The first word is enthalpy of formation. This means the heat change when one mole of a compound is formed from its elements in their most stable state at the standard condition. Standard condition means 1 atm and 296 Kelvin. So the example is H2 in the gaseous state and 1/2 oxygen in the gaseous state will form the compound, which is H2O. And the second one is enthalpy of atomization. Enthalpy of atomization means the heat absorbed when one mole of gaseous atom is formed from its element. So the example is this. The sodium in the gaseous state will be formed from the sodium in the solid state. And the third one is lattice energy. Lattice energy means the energy released when one mole of the solid ionic compound formed from its gaseous ions. This is the example. The sodium ion in the gaseous state and the chlorine ion in the gaseous state will form the compound sodium chloride in the solid state. So this means lattice energy. So the last two words is electron affinity and the ionization energy. We can know the meaning of electron affinity and ionization energy from the words. Electron affinity, so you can see, is gain the electron. Ionization energy is become the ion. So the definition of electron affinity is energy change when one mole of gaseous atoms gets one mole of electrons to form the anion. So the example is this. The oxygen in the gaseous state will gain one more electron to become the oxygen ion in the gaseous state. So for the ionization energy, this means the minimum energy required to remove one mole of electrons from one mole of gaseous atoms or ion. So the example is the magnesium in the gaseous state will become the magnesium in the gaseous state, which is the magnesium ion, and it will also release the one mole of electron at the same time. So that's all about the words that will be used in the Born-Haber cycle. We will proceed to the problem and solution.
Now I will talk about where to draw the energy level diagram in Born-Haber cycle. The energy level diagram will show the increase or decrease in enthalpy, and I will draw it according to the flow from the enthalpy of formation of Na2O until the lattice energy of Na2O. Firstly, we will draw the arrow at the left, and it will pointing outward, and we label it as enthalpy. After that, we need to draw the origin. Beside the origin, we need to draw a horizontal line. On the line, it will be the elements in their stable state, which is 2Na in solid state and half O2 in gaseous state. These are the reactants in the equation for the formation of sodium oxide. Take in mind the arrow for positive delta H is outward and the negative delta H is downward. Due to the enthalpy of formation of Na2O is negative, the arrow must point downward. And make sure our arrow must touch both of the line. And here we will write the enthalpy, and level is at 1. Now here we will write the enthalpy, and it will be negative 414 kilojoule. And the product will be Na2O in solid state. After that, we need to draw about the atomization of the Na. The atomization of Na is positive, and we will need to draw the arrow upward. The arrow must draw beside the Na because this is about the change at Na. From the question, we need to find the atomization of Na. We do not have the value and we just put it as x. And because we have 2 Na, we need to write 2x. The product will be 2 Na in gaseous state because after the atomization, the product will be in gaseous state. The half O2 is remain same because the atomization of Na is only include the Na. Next, the atomization of oxygen is positive, so the arrow need to be pointing outward. Then the arrow is beside the O because it is about the oxygen. The enthalpy of atomization of oxygen is positive 249 kilojoule. And now the Na is remain constant, and the half oxygen already become O in gaseous state. After that, we need to draw about the ionization energy of Na. According to the question, it is positive, so we draw the arrow upward. We draw the arrow is longer than before because the value of the ionization energy of Na is bigger than before. Moreover, the value of ionization energy need to be double because of we have 2 Na. But the given value of ionization energy of Na is just for 1 mole. Hence, the 496 is just for 1 mole, and after it is double, it will become positive 992 kilojoule, and this is for 2 Na. Because the Na is donate electron, so it is become Na plus in gaseous state, and we have O in gaseous state. After that is about the electron affinity of oxygen. The first electron affinity is negative. The arrow is pointing downward. The first electron affinity is negative 141 kilojoule. And now the 2NO positive in gaseous state is still same, but the O is already gain an electron, so it is become O negative in gaseous state. After that, the second affinity is positive 750 kilojoule. Because it is positive, so the arrow is upward. Positive 750 kilojoule. And here the 2 Na plus in gaseous state is not changed. And the oxygen already gained 1 electron and become O2 negative. Lastly is the lattice energy. The product of the lattice energy will be Na2O in solid state. So the arrow must reach the line at the Na2O. Lattice energy of NaO is negative due to the negative, so the arrow is pointing downward. Lattice energy is negative 2478 kilojoule. And now it will become a complete cycle. It's done. After that, my friend will show the second method to draw the Born-Haber cycle.
So now
with the second method on how do we draw the energy level diagram. So firstly, we will start with our product, which is sodium oxide, Na2O, in solid state. So we know that this Born-Haber cycle is formation of ionic compound. So there will be metal and non-metal. So our metal will be Na in solid state, and our non-metal will be O2 gas. And then we need to balance out the equation, but we cannot put anything in front because you need to remember the definition of enthalpy of formation, which is 1 mole of compound. So we can only change for our reactant. So we can add 2 in front of Na, and we will add 1/2 for oxygen. And then our Na, it will undergo enthalpy of atomization to form 2 Na in gas state. And then the value for enthalpy atomization is what the question asks us to find. So we can put it as 2x. It's 2 because there is 2 mole of natrium. And then natrium will undergo ionization energy, where it will release electron to form ions. So it will form 2 Na plus gas. Ionization energy is also given in the question, which is 496. So we need to multiply with 2. We will get positive 992 kilojoule. We will proceed to our oxygen, which will undergo enthalpy of atomization, which is given in the question, positive 249 kilojoule. And we will get atom oxygen gas state. So oxygen will undergo Ea, which is electron affinity, where it will gain electron, and it will undergo Ea twice. So the first one, we will get O minus, and the value is given, which is negative 141 kilojoule. And then it will undergo Ea again to form O2 minus. And this is the value given in the question is positive 750 kilojoule. So now we get cations and anion, and these two will combine to form our product, which is Na2O. And here we will get lattice energy, which is also given in the question 2478. And don't forget, lastly, to label enthalpy formation of sodium oxide, also given in the question as negative 414 kilojoule. So this is the completed energy diagram for the second method.
Okay. Now we continue to the second question, which we have to calculate the enthalpy of atomization of sodium. Here, we're having the atomization of sodium, which is 2x. We have to find what is the value of x. In finding x, firstly, we have to look at the energy level diagram and find out all the detail and identify it. Firstly, we're having this. We're having the overall enthalpy of overall reaction, which is negative 450 kilojoule. So the flow must be anti-clockwise, which, as you can see here, we're going up, downward, and finally in this part to complete become an Na2O in solid. So firstly, I want to show you that in doing the calculation, you must know the flow on putting all the enthalpy. This is the first one, the first enthalpy. This is the second enthalpy, the third enthalpy, the fourth enthalpy, the fifth, and the sixth one. And if you calculate all this enthalpy, you will get the overall enthalpy, which is this. This is how you identify and look when you're having this kind of diagram. And I will show you if you want to find in the sea level diagram. Okay, and now I will show you in finding the second part, which is when you using the energy level diagram in this type of structure. Firstly, as you can see here, we're having the overall over here for Na2OS, Na2 solid, and the enthalpy of is one direction. The arrow for enthalpy is one direction. We go here, 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 and here, crossing this one. So, in doing the calculation, you have to list out step by step, which is starting from here. This is the number one enthalpy in the number one enthalpy, the number two, number three, number four. Here is number four, and number 5 and 6. When you calculate all of this, you will get this value, which is negative 414 kilojoule. Now I will show you how to do the calculation. Okay, let's start on calculating the enthalpy atomization of sodium, which is X. So, firstly, we're having this. So, in doing this, we're having to follow the flow, which is this one equals to, we're having calculate all this, we will get the negative 415. So, just substitute the value, erase this value, 249 minus 141 plus 750 plus 2x, that is our key, 2x plus 496 minus 2478. Okay, when we do the calculation, use the calculator and we'll get the value of X, which is 107 kilojoule per mole. Why are we having the per mole? Because this is enthalpy of atomization, which is having one atom. So one atom per molecule, you get this. Okay. In case we're having the tricky question, which if I change this one is enthalpy formation, atomization of sodium. What if I change the question? Okay, in that case, when we're having the other kind of question where they already give you the value of 2x from the previous answer, we got 107. So if the question changed and they ask, what is the enthalpy of this reaction? Maybe in this reaction, the lattice energy. How to find the lattice energy? So formulation, we don't have this. Okay, they replace this answer with y. So we have to find the value of y. So you don't have to worry, since even though they change the places, change the type of question, you have to keep in mind that every step in finding this answer is the same. So we just refer to the formula, which is the enthalpy of overall reaction equals to enthalpy of each reaction. So By that, you have to simplify and finally you will get y equals to the answer. So don't worry. Okay. Now I will love to give you few tips on identifying and doing when you found the Born-Haber cycle question. Firstly, you must identify these 5 things. F-A-I-E-L, file. These things, which are F stands for the formation. You must know the question, which are the products? What is the product product is from? And for A, it stands for atomization. And the third one, I stands for the ionization energy. Okay. And E stands for the electron affinity. Electron affinity. Okay, the last one, we have the L. L stands for the Lattice Energy. Okay, this one. So, this is the tips. Number 1, you must identify these 5 terms. Okay, let's move to the second tips. When you want to do the line, the arrow, you have to focus that someone will confuse how to decide the arrow go to upside or the downside. So the tip is, when you get the enthalpy of the product of enthalpy of the atomization or what so on, when it comes to positive, always bear in your mind, positive always go to upward. When it's negative, negative go to the downward. Okay? So the third tips is when you want to do the line of the arrow, you have to make sure your line of the arrow is proportional to the magnitude. Since if you having the enthalpy, this one, for example, this enthalpy may be about positive 100 kilojoule. And if you want to do the enthalpy for the other reaction, the other one, the enthalpy that higher than the first one, positive maybe 250 kilojoule, make sure the length is also longer than the first one. Okay, you have to differentiate. Not every line having the equal of the in the length. Okay, I want to give the fourth tips, which is, if you done doing all of the energy level diagram, make sure all point is correct. Okay, the line follow the order, and you must identify which all these things, the field. Thank you.
That's all from us. Good luck for your PSPM. Bye!